Hey guys, it's Final Exam Guy, and today we're going to be going through 5 solved problems in mechanics, 2-directional motion. Before we start, just subscribe. You can support me by subscribing to my channel and sharing these videos with your friends so that everyone can learn about mechanics. So let's get started here. We got a problem that says a stone is thrown from the top of a building upward at an angle of 30 degrees to the horizontal with an initial speed of 20 meters a second, as shown. The height of the building is 45 meters. How long does it take the stone to reach the ground? And what is the speed of the stone just before it strikes the ground? Alright, so I've set up our coordinate axis here, so the positive y is upward, positive x is rightward. So we've got a building, the stone's being thrown off on it. It's 2-directional because we have an x component of velocity and a y component. We're given an angle and the height that the ball travels. So we need to set up a reference frame here. So we're starting at the top of the building. So the stone hasn't traveled anywhere. So we're starting at initial height of 0 meters, and we're given the final height that it traveled. The distance that it travels is 45 meters. That's the final height. But the thing to know is that we're going downwards, so it's got to be a negative here, following this convention here. We're given our V initial, 20 meters a second, and our theta is 30 degrees. In order to analyze problems like these, we have to break up the velocity into components, because we can't just use 20 meters a second and plug it into our equations. We'll get it wrong because there's equations for the x horizontal and for the vertical. There's different equations, right? So if we go and transform our velocity into the x component, it would be 20 cosine 30 degrees. And we get 17.3 meters a second. Do the same for our y, except with sine 20 sine 30. We get 10 meters a second. So now we successfully broke it up into components. And in your textbooks, or you should be memorizing this by now, there's a formula to calculate final height in terms of initial height, velocity in the y, and acceleration in the y. So it's y final is equal to y initial plus v y initial t plus 1/2 at squared. Acceleration here is the gravitational acceleration because we're going in the vertical direction. So we plug in our knowns. Negative 45 is equal to 0 plus, and as this velocity here is going to be, it's going to stay positive here because we're traveling at this angle, so velocity will be positive upwards, 10t plus. Now acceleration is negative because it's accelerating downwards, 9.8 t squared. So now we get solve for t, and the answer just gets, I encourage you guys to always try to solve for it. The answer is 4.22 seconds. That's the time it takes to reach the ground. So now part B. Part B is asking us what is the speed as it reaches the ground. So to solve this part, we're going to need to find our x component velocity and our y component velocity as it hits the ground, and then we're going to take the magnitude, that is square them and take the square root to find a combined velocity. So in your textbooks, or you should know this by heart by now, velocity y component final is equal to velocity y component initial plus ayt, where a as your acceleration and gravity. So we can do this by plugging it in. So we know our velocity in the y, it's just 10, and we got plus the negative 9.8 acceleration meters a second squared times our new time that we just solved for, 4.22. We get a value of negative 31.3 meters a second. So now all that's left to do is find the x component final velocity, and there's no there's no, you don't need to find it basically, because according to my buddy Newton, it says that an object in motion will stay in motion, right, unless a force acts upon it, right? So in this case, the only force we have acting is the gravitational pull, which only acts vertically. So that means the horizontal component will not change. The velocity will stay the same, initial and final. So it's going to be what we found on top, 17.3 meters a second. So our total final velocity would be the magnitude. So negative 31.3 squared plus 17.3 squared, all under a square root, and we get an answer of 35.8 meters a second. Alright, let's move on to question 2. Alright, so this problem here, we got a ski jumper who's leaving the ski track, moving in the horizontal direction with a speed of 25 meters a second, as shown in figure below. The landing incline below her falls off with a slope of 35 degrees. Where does she land on the incline? Okay, so write down our givens. We're given velocity in the x, 25 meters a second. And there's no vertical in this problem. It just gives us there's only a horizontal, it tells us. So 0 meters a second. So they're asking us for where does she land. So her x final position and her y final position. If you look at this triangle here, we can see that this her x final position in horizontal direction has to be D, and it will be, if you look at the triangle. Let's just make quick sense of this triangle before we move forward. So skier leaves horizontally at an angle downward slope 35 degrees. So that means this angle must be 55 degrees. And we know that a right triangle, this is 90. So this also here must be 35 degrees. Or you can use the alternate angle theorem. If this is 35, this has to be the same thing. So this would be our y final distance, and this would be our x final distance. So we need to find those. And if we call this d, which it does give us d in the problem, you know that yf, d sine 35, and this is negative because we're going downwards, and x final is d cos 35, right? So writing it here, y final equals negative d sine 35. Okay, and now we have to just apply the formulas. So given in your book, for x direction, 2D motion, x final is equal to vx initial times t. And we have both here, so we can isolate for d cos 35 is equal to 25t. And now we can also write the one for vertical. This equation is given as well. Y final equals Vy initial, which is a 0 in this case, plus 1/2 AY t squared. So we know that negative d sine 35 is equal to 0 plus, and the acceleration is negative for gravity, so we have negative 1/2 9.8 t squared. So all that's left here, guys, is we got two equations, equation 1, equation 2, two unknowns. So we solve here for t. We get d cos 35 over 25. If we plug this t into this equation, we get negative d sine 35 is equal to negative half 9.8 times d cosine 35 over 25 squared. And if we solve for d, we end up getting d is equal to 109 meters. So to find the x final, we knew that it was d cos 35, so 109 cos 35 gives us 89.3 meters, and y final negative 109 sine 35. This is negative 62.5 meters. Alright, let's move on to question 3. Alright guys, now that we've got some 2D linear motion out of the way, let's do tangential and radial acceleration problem. So a car exhibits a constant acceleration of 0.3 meters a second squared parallel to the roadway. The car passes over a rise in the roadway such that the top of the rise is shaped like a circle of radius 500 meters. At the moment the car is at the top of the rise, its velocity is horizontal and has a magnitude of 6 meters a second. What is the magnitude and direction of the total acceleration vector for the car at this instant? Alright, so they're giving you the tangential acceleration. So if you have you're traveling in a circle, at every point there's a tangential acceleration, right? The particles going around in a circle. And there's always an acceleration component that goes towards the center if you're revolving around the circle, and that is your radial acceleration. So this is exactly what's happening here. If I can draw, we've got our car with an acceleration triangle, so this would be our A tangential, and there's always a acceleration radial going towards the center of the circle. So combining this would be our magnitude and direction of the total acceleration vector. So all we got to do here is pretty much find the radial acceleration, and tangential is given to us already. So 0.3 meters a second squared. So we know that the formula for the radial acceleration is negative v squared over r. And we're given our v, so negative 6 squared over 500 meters given in the problem. We're going to be getting negative 0.072 meters a second squared. Okay, and now it's just as simple as computing the magnitude, so square and square root. So 0.3 squared plus negative 0.072 squared. That gives us our magnitude, 3.09 meters a second squared. And to find the direction, phi, angle in this case, is just tan inverse of radial over tangential equals tan inverse negative 0.072 over 0.3. And our final answer is negative 13.5 degrees. Let's go to question 4. Alright guys, question 4, let's do a relative motion problem so we cover all of two-directional motion. So a boat crossing a wide river moves with a speed of 10 kilometers an hour relative to the water. The water in the river has a uniform speed of 5 kilometers an hour due east relative to Earth. If the boat heads due north, determine the velocity of the boat relative to an observer standing on either bank. Alright, let's draw this out. So we got the banks, water in between. So we got our boat. It says it's heading due north. Okay, our boat's draw better. It's heading due north with a velocity of 10 kilometers relative to the water, right? So 10 kilometers with respect to the water. So you would write B both with respect to water. And then the water is moving due east with a speed of 5 kilometers. So V water with respect to Earth is equal to 5 kilometers an hour. And if the boat heads north, determine the velocity of the boat relative to an observer standing at the either bank. So this velocity is what we're trying to find. This is the velocity of the boat with respect to Earth. This is how these relative triangles work. So how to find this? We would do the following. We got our vector triangle. We know that this is 10 kilometers velocity vector. Fortunately, the water is going due east with respect to Earth, and this is 5. So all we got to do is Pythagoras' theorem. So c squared equals a squared plus b squared So c squared equals 10 squared, which is 100, plus 25. C squared is equal to 125. So c is equal to 11.2 kilometers an hour. Alright guys, so part B says if the boat travels with the same speed of 10 kilometers an hour relative to the water and is to travel due north, as shown in figure 4.21b, I'm going to draw the figure for you guys. What should its heading be? Alright, what does its heading mean? We have the same triangle, it's just that it's a little different now. Hold on. It's the heading means that it basically means that the velocity of the boat with respect to Earth must be across the river this time, and the river is still heading with respect to Earth is this way, and this would be the velocity of the boat with respect to the river. This is what they're asking for by heading, and it's vectors. So you want to get the direction and magnitude. So to solve this, we already have some of these values to plug in here. Before we write those values in, we're solving for this angle and this magnitude here. So what velocity must the boat travel with respect to the Earth, in what direction, so that if the river is going to push it to the right, it's still going to end up going north straight up. That's basically what the question is asking. So we're given this already. It's 10. And the velocity of the river with respect to Earth is 5. So it's another Pythagoras' theorem. So c squared is equal to a squared plus b squared. So we got 100 is equal to 25 plus, call this a, call this b. So 100 minus 25, 75 is equal to b squared. So b is equal to 8.66 meters a second. And our phi angle from the triangle will be phi is equal to, or theta, tan inverse 5 over 8.66. So it's equal to 30 degrees. So what this means is that the boat has to head upstream, so it travels directly north across the river. And for this situation that we have, the boat has to steer a course of 30 degrees west of north. And if the current was much faster, the boat has to be aimed upstream at even larger angles. So I hope you guys understand that. Alright, so a farm truck moves due north with a constant velocity of 9.5 meters a second on a limitless horizontal stretch of road. A boy riding on the back of the truck throws a can of soda upward and catches the projectile at the same location on the truck bed, but 16 meters farther down the road. In the frame of reference of the truck, at what angle to the vertical does the boy throw the can? I put an observer here because he sees something differently than if you're actually on the truck looking at the can. So if you're on the truck looking at the can, you'll see that the ball goes straight up, straight down. It forms no angle with the vertical. So the angle here would be 0. What is the initial speed of the can relative to the truck? To find initial speed, we're going to have to apply a formula. First, we're going to have to find the time of flight of the can. So you'll see why that makes sense. So if we use the formula, the general formula, x is equal to v initial t, where this is v horizontal initial, plus 1/2 at squared. The truck is traveling horizontally with a constant velocity, so there's no acceleration. And we know that the ball, the can is in the air up until 16 meters farther down the road, so 16. And the velocity, we use the one of the truck, and t. So we find that the time of flight is 1.68 seconds. So now that we have the time of flight, we can use a formula to find the actual initial velocity of the can itself. Because right now we only have the velocity of the truck. The initial velocity of the can would be found using the equation in your book, y final plus vy initial plus 1/2 gt squared. This time we have acceleration, it's gravity. So the final height of the can is he throws it up, so initial height is 0, and it ends up back in his hand, so the final spot is still 0, so they're both 0. So plus vyi, that's what we want. I forgot to put a t here, sorry guys. T, vyt, and plus 1/2, 9.8. And we're given the times, we found it, 1.68 squared. If you solve for this, you get that vy initial is 8.23 meters per second. So that's the initial velocity of the can relative to the chuck. So let's go on to question C. It says, what is the shape of the can's trajectory as seen by the boy? So if you're on the truck, imagine you're on the truck and your truck is moving and you shoot the can up in the air, all you're going to see is it going up and down, right? You're not going to see any curve or anything. To you, it's just going to look like it's traveling from your hands up, 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 and down, right? So that's it. That's the trajectory of the ball as seen by you. And now question D says an observer, what does he see? And it asks you to determine the initial velocity. So look, an observer on the ground watches the boy throw the can and catch it. In this observer's ground frame of reference, describe the shape of the can's path and determine the initial velocity of the can. So it's the initial velocity to the observer, not to the truck. So if you're observing this this truck zoom past you, and the boy throws the ball in the air, you're gonna see kind of like the ball initially going up, but the truck is moving, right? So it's gonna go like, you're gonna see the ball going like this. You know what I mean? I hope you can picture it. And then eventually you're gonna see it going down, right? So it's kind of gonna, for you, it's gonna form a path like this. You gotta really visualize this. Obviously, you're not gonna see the ball going straight up and down, no, because the truck is moving with it. It's gonna like drag the ball along. So the theoretical shape that it would take on is a parabola downward. So that is your answer. And so to find the velocity in the frame of reference of the observer, so the truck would move horizontally to the observer. It would be moving, so the velocity of the can in the horizontal is the velocity of the truck, and we had said that was 9.5 meters a second. And if you think about it, the observer would still see the ball traveling up and down in the vertical direction at the velocity that we had found earlier, 8.23 meters a second. So to find what the total velocity that the person sees, you have to take the magnitude of this. So it would be 9.5 squared plus 8.23 squared. So this is what the observer would see, 12.57 meters per second. So, and to find the direction of the projectile above the horizontal and the frame of reference of the observer, you just do theta is equal to tan inverse 8.23 by 9.5, and we got 41 degrees. Alright guys, so that concludes 2D motion solved problems. I really hope you learned something today. I hope my explanation was clear. If you have anything, comment down below, and support me by subscribing to my channel, and don't forget to smash that like button and share this video with people you know so that they can learn about 2D motion as easy as possible. So I'll see you guys in the next solved problems.